Part 4. Not going to do this whole thing while recording, so I'm just going to get this started. So what we have to do is triple whatever theta is, then take cosine of that, then multiply that by 5. So a little PEMDAS. So let's start with 0. Pretty simple. So 3 times 0 is 0. Again, make sure your calculator is on degree mode. So we're going to go cosine of 0 degrees. And then that's 1 times 5 is obviously 5. Now I'm going to do 30, and then I'm just going to fill the rest in without recording. So 30 times 3 is 90, so I got to take cosine of 90. That's 0. 0 times 5 is 0. Let's see where this weird one goes. I'll be right back. Okay, just give you a little peek. I've gotten started. I tried going by chunks of 30, but I could tell that was just not going to fill in the actual drawing, so I decided to go chunks of 15. So 0, 15, 30, 45, 60, 75, 90, 105, and so on. And I plotted all these points. I'll just show you one of these. So 3.5, so I go out 3.5. I spin at 75, which means 60 plus 15, which takes me here. But then I have to go directly opposite 3.5, which would drop me right here. And you can see, after plotting all of these, I'm getting a general idea of what this is going to look like. But this side hasn't been completed yet. So I need to keep going on my little journey until that's filled out to answer these questions. So I'll fill some more out and show you what's up. Okay, so I got to this one, and I know I only need one more point, which this makes sense. If I plugged 165 in, I get negative 3.5. So my radius is 3.5 right here. Spin it 15 degrees short of 180, which would be about here. Go polar opposite, and 3.5 would be there, and you can see that this little pedal has been completed. So you might say, well, you only have to go to 165, 166, 167, because then you'd be like filling all these in. Ultimately, I believe 180 will be our smallest interval again to fill out this whole pedal. So there it is. Let's move on. Alright, these should move pretty quick. Remember, I equals the square root of negative 1. Anytime you square I, you get negative 1. A lot of people see this and they FOIL, but they don't see the obvious. They just distribute this. So it's 4 plus 3i minus 2 plus 4i. So 4 minus 2 is 2 plus 7i. You're perfectly fine, Bart. Come on in. You just became part of the recording, buddy. So now part B is a classic FOIL problem. 4 times 3 is 12. Outside would be 16i. Inside negative 6i. All you can do is make a silly mistake. Minus 8i squared. Now this is where the fun is. That's actually minus 8 times negative 1, which is a negative 8. Two negatives make a positive, so now we have 12 plus 8, which is 20. 16i minus 6i is 10i. This one, do not square this and think you're all good. You have to square the binomial, which means square the binomial. So FOIL it out. 9 minus 15i minus 15i plus, negative times a negative, 25i squared. What's i squared? Negative 1. So this is actually negative 25. So 9 minus 25 is negative 16 minus 30i. A little shortcut that's not really a shortcut. Square that. What do you get? 9. Multiply these two together, double it. What do you get? Negative 30i. Square that. What do you get? 25i squared. Negative 25 plus 9, negative 16 minus 30i. Not much of a shortcut, but it is. This one, get the radical out of the basement. Don't start canceling these. For example, 7, let's go plus 2, over 8 plus 2. You would never, I hope, cancel these 2's and say, oh, my answer is 7/8. If it was 7 times 2 over 8 times 2, for sure. But not when you have addition. Doesn't work. So you can't just start canceling these things out. So 1 plus I, you got to multiply by the conjugate. We don't really worry about what's in the top. We worry about what's in the bottom and multiply by the conjugate. So in the bottom we can fool. In the top we have to FOIL. So 1 times 1 is 1. Outside, inside. Going to do a little outside, inside together. I times I is I squared, which is -1. 1 minus 1 cancels, so it's just 2I in the top. Now to fool, we get 1 minus I squared, which is 1 minus a -1, which is actually 2. So the 2's cancel, so you're left with I as your answer. Okay, let's move on to number 13. So this says if u is 3 minus 4i, find u times this weird looking thing. That's just a weird, this is built off the conjugate 3 plus 4i, and now you can just fool. 3 times 3, you can FOIL, but we're not gonna. 3 times 3 is 9, minus 16i squared, which is 9 minus 16 times -1, which is 9 plus 16, which is 25. Okay, number 14. I've already drawn the drawing. So z, -12 minus 5i, -12 minus 5i. So if we use a little Pythagorean theorem, it says to find the argument and the modulus. So we're going to go for it here. It's 144 plus 25. Some of you have already beat me to the punch here. It's a family. So that's 13. And remember the family, 5, 12, 13. So we've got that. In there. I could use sine, cosine, or tangent. I'm going to go ahead and stick with tangent because that's what we've been doing. Opposite over adjacent. So negative divided by negative is positive. So it's going to give me some answer in the first quadrant. So be prepared for that. So this is the same thing as opposite over adjacent. $22.6. So if I listen to the calculator, it gave me that drawing, which means this is 22.6. So 180 plus 22.6, 202.6. And we're done, except for it says now write it in polar form. Well, that should be 6. Don't forget, polar form just means r theta instead of rectangular form, -12, -5. Okay, on to number 15. So remember, according to our polar form formula, this is just r, and this is our argument, just given to you differently. And this is called trigonometric form, but that's just how to decode it. So really, we got to have 2, 3 pi over 4. It says write it, the complex number in standard form, which means a plus bi. That doesn't mean that has to be a plus. But if we said, okay, my spinner's 2, I got to spin it that far. That's 3 times 45, which is 135. So I go here, I spin it, 135, boom. There's my drawing. My spinner's 2 units long. If this is 135, that leaves this as a 45. Finish your triangle by coming this way. I got to divide by the square root of 2 to get this and this. So we get that radical out of there. 2 square root of 2 over 2, gone. This has to be negative. This has to be positive. And so this is my x-axis, this is my y-axis, so this would be negative 2 plus, whoops, negative square root of 2 plus I square root of 2, which means left square root of 2 up the I-axis square root of 2. So there'd be your answer for that guy. Same sort of situation here. My spinner's 6 units long. I got to spin it that, which is 5 times 60, which is 300, which is 270 plus 30. We're going to stop it right there. Finish our triangle by going back here, which means this 6 is pointless. Now this is 30, this is 60, 90. If that's 6, this is 3. If that's 3, this is 3 square root of 3. Negative, but this is my x-axis, my y-axis. So standard form would force me to go 3 minus 3i square root of 3. They don't want you to go like this because students will make that too long. It just looks wrong. So that's why they put that little guy right in there. That's a better answer. And that completes Unit 11 test review. Good luck. Like and subscribe.